we're going to see for what values of x does the series negative 1 to the n, x to the n, 4 to the n log n converge. So we're going to use the ratio test for absolute convergence, which means we're going to look at the limit as n approaches infinity, the absolute value of a sub n plus 1 over a sub n. And that limit will give us an expression which we then force to be less than 1 for convergent. So the limit as n approaches infinity, a sub n plus 1, I just put in an n plus 1 and I get absolute value. I can ignore the negative 1 to the n with the absolute value sign. It's x to the n plus 1 over 4 to the n plus 1 log n plus 1. And then we're dividing that by the a sub n term, which is x to the n over 4 to the n log n. Okay. So now I'm going to invert to multiply, and we get limit n approaches infinity, x to the absolute value x to the n plus 1, we get 4 to the n log n over x to the n 4 to the n plus 1 log of n plus 1. We can actually cancel. This becomes an x, the 4 to the n with the 4, and there's nothing I can do with log n over log n plus 1. So this is the limit as n approaches infinity, x times log n over 4 times log of n plus 1. So now log n and log n plus 1 are positive, so I can write this as limit n approaches infinity, log of n over log of n plus 1 times the absolute value of x over 4. So separately, because there is no property of logs, I have to do this limit. And the limit as n approaches infinity, log n over log of n plus 1 is infinity over infinity. By L'Hopital's rule, it is limit n approaches infinity, derivative of log n 1 over n, derivative of log 1 over n plus 1. And this becomes limit n approaches infinity, n plus 1 over n, which is infinity over infinity. And again, L'Hopital's rule is limit n approaches infinity, derivative of n plus 1 is 1, derivative of n is 1, limit of a constant is 1. So I've just found that this limit is 1, so the limit is 1 times the absolute value of x over 4, and that is my L value. But by the ratio test, we must make L less than 1. So absolute value of x over 4 less than 1 can be written as negative 1 less than x over 4 less than 1. And multiplying through by 4, I have 4 less than x less than 4. So I have the first step. I have the interval where all those x values will make this series converge. But I'm concerned about what happens when L is 1, and that's when absolute value x over 4 is 1, which makes x positive 4 and negative 4. We're going to have to check the endpoints. So we are going to have to substitute 4 and negative 4 to see if those endpoints work. I'm going to let x equal 4. So I'm going to substitute x equal 4 in the original series, which is negative 1 to the n, x to the n, 4 to the n, log n. And that becomes, as n goes from 2 to infinity, negative 1 to the n, plugging in 4, I get 4 to the n, divided by 4 to the n log n. The 4 to the n cancels, and I am now looking at the alternating series 1 over log n as n goes from 2 to infinity. We need to now use the alternating series test. So first I know f of x is 1 over log x, that's my b sub n, which is log x to the negative 1. So the derivative is negative 1 log x to the negative 2 times 1 over x. So it's negative 1 over x log x squared. That's a negative, and this is positive and positive for x greater than or equal to 2. So we now know that this is negative. The last part of the alternating series is that the limit as n approached infinity of b sub n, which is limit n approaches infinity 1 over log n, is 1 over infinity is 0. So we know that this alternating series, when x was 4, it converges. What that tells us is that I can put an equals here for the 4, because I know with x being 4, at that endpoint, it did converge. Now I'm going to let x equal negative 4, and I get series negative 1 to the n, negative 4 to the n, over 4 to the n log n. But I can write this as series negative 1 to the n. Negative 4 is negative 1 times 4, so it's negative 1 to the n, 4 to the n, over 4 to the n log n. And so this becomes series n goes from 2 to infinity, negative 1 to the even 2n. The 4 n's will cancel, and I've got 1 over log n. So this is the series from 2 to infinity, 1 over log n. This test, though, that we're going to have to use is the comparison test, and we're going to compare it to b sub n being 1 over n, which we know diverges. I'm going to go to the next page to do that. So I have to use the comparison test. And in doing that, I have to show that log n we know is less than n. Several ways of doing this. N can be written as log of e to the n. And clearly then I can say that n is less than e to the n. When I take the log of both sides, I get log n less than n, and reciprocal I get 1 over log n greater than 1 over n. Therefore I showed that a sub n greater than or equal to b sub n for all n greater than 1. Because b sub n being 1 over n diverges, therefore it diverges. The result of this is that my original interval, negative 4 less than x less than 4, I got that when x was 4 it converged, but when x was negative 4 it diverged. So this is called the interval of convergence, and it is the interval from negative 4 to 4, which means that everything in my original power series converges provided you substitute x being in that interval.